Hello everyone. In this video we are going to solve the problem number 1.33 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A cannon fires successively two shells with the velocity of v0 is equal to 250 meter per second. The first at an angle of theta is equal to 60 degree and the second at the angle theta is equal to 45 degree to the horizontal. The azimuth being the same, neglecting the air drag, find the time interval between the firings leading to the collision of the shell. So let us say this is the point from where the two shells are fired from the cannon. So let us say this is the horizontal direction and this is the vertical direction. Let us say this particular shell is fired at an angle of 60 degree and the velocity is 250 meter per second. Okay, so this is the path it will follow. And if we talk about the second one, then the second particle is thrown at an angle of 45 degree and the path it is being followed, let us say this one. And these both particle, let us say they will collide at this particular point. Okay, this is the particular point where both the particles will collide. Both the particles will collide, let us say. Okay, now if we see here, the distance from where it has fired is the horizontal distance as well as the vertical distance, both are same for these two particles. Okay, so let us say this is the particle 1. It is taking the time of t plus delta t because it was fired before this one. So it is taking the time of t plus delta t to reach here, and let us say it is taking time of t. Okay, so let us first write the initial velocity in the horizontal direction. So this is the initial velocity in the horizontal direction. For particle 1 will be 250 into cos of 60 degree. Let us say this is for particle 1. And for particle 2, the horizontal velocity will be 250 cos of 45 degree and the vertical component will be 250 sin 60 degree, and for particle 2 the vertical component will be 250 into sin 45 degree. Now we have just stated that the horizontal displacement for both the particles will be the same. So we can write the horizontal displacement is equal to initial velocity in the x direction into time plus half into acceleration in the x direction into t square. As the acceleration in the x direction is 0, so the second term here will be 0. Okay, so here we can write the displacement of the particle 1 is equal to displacement for particle 2. Okay, so initial velocity for particle 1 is 250 cos 60 degree, okay, into time taken is for particle 1 is t plus delta t. T plus delta t is equal to the velocity for the particle 2 is 250 into cos of 60 degree into t. So from here we can write t plus delta t is equal to 250 into, this is 45 degree. So cos 50 degree is how much? 1 by root 2, and cos 60 is 1 by 2. So from here we will get t plus delta t is equal to root 2t. Okay, now in this from here we got the value of t plus delta t is equal to root 2t, but we have to find out the time difference, that is delta t. Okay, for that we will equate the vertical displacement as well, let us say sy. So we can write Sy, the vertical displacement for particle 1, is equal to the vertical displacement for particle 2. What is the vertical displacement for particle 1? That is the initial velocity in the y direction for particle 1 is 250 sine 60 degree. So we can write 250 sine 60 degree into t plus delta t minus half into g into t plus delta t whole square, because the acceleration in the negative y direction, that we can equate it to the vertical displacement of particle 2, that we can write it as initial velocity for the particle 1, that is 250 sine 50 degree into t minus half into g into t square. Let us substitute the value of t plus delta t from here to this particular expression. Then we can get 250 sine 60 degree into root 2t minus half into g into 2t square is equal to 250 sine 45 degree into t minus half gt square. So from here we can write 250 sine 60 degree is root 3 by 2 into root 2t minus gt square is equal to 250 into sine 45 degree is 1 by root 2 into t minus gt square by 2. Okay. So if we calculate the value of this one, that is 250 into root 3 divided by root 2, then we can get 306.19 t minus gt square by 2 is equal to 250 divided by root 2, we can get it as 176.78 t. So from here we can write gt by 2 is equal to 306.19. So we can write 129.41. So from here we can write t is equal to 129.41 into 2 divided by g. So this is the value of the t at which they will collide. Okay. Now we have to find out the value of delta t. So we can use this particular expression. So we can write t plus delta t is equal to root 2t. So from here we can write delta t is equal to root 2 minus 1 into t. So from here we can get delta t is equal to root 2 minus 1 into 129.41 into 2 whole divided by g. So we will get the value of delta t is equal to root 2 minus 1 into 129.41 into 2 whole divided by 9.81. So from here we will get 10.93 seconds. Okay. So this is the value of the time difference we got here. So this is what it was asked in the problem, that find the time interval between the firings leading to the collision of the shell, and the shell is colliding at this particular point. I hope the entire procedure is clear. Thank you.